This video is on the pH scale in acids and bases. Autoionization of water is a reaction where water is seen to react with itself. Recall that water can be a proton donor, an acid, or a proton acceptor, a base, in the Bronsted-Lowry theory. Because of this, water is amphiprotic. The K equilibrium is symbolized Kw and is the product of the concentration of OH minus ions and the concentration of H3O plus ions, which is equal to 1.0 times 10 to the minus 14 at 25 degrees Celsius. Kw is known as the ion product constant for water. In the autoionization of water, the chemical equation can be written where water reacts with itself, or because the hydronium ion H3O plus is actually an H plus that is hydrated, H plus with water. Both H plus and H3O plus mean the same and are used interchangeably in chemistry. Then water dissociates to the hydroxide ion OH minus and the proton H plus. The ion product can be written Kw is equal to the concentration of OH minus times the concentration of H3O plus, or it can be written as Kw is equal to concentration of OH minus times the concentration of H plus. The product of these two ions must equal 1.0 times 10 to the minus 14. So a neutral solution is when the concentration of OH minus is equal to concentration of H plus, and each of these are equal to 1.0 times 10 to the minus 7. A solution is neutral when the concentration of the hydroxide ion is equal to the concentration of the hydronium ion, or the proton, which is equal to 1.0 times 10 to the minus 7. The molar concentration of the hydronium ion is small in solution. Chemists use pH to express the concentration of H+, the hydronium ion, and pOH for the concentration of hydroxide ion OH-. So the pH is equal to the negative log concentration of hydronium ion. A pH of a neutral solution is 7. The pOH is equal to the negative log concentration of the hydroxide ion, where the pOH of a neutral solution is also 7. In aqueous solution, the concentration of both hydronium ion and the hydroxide ion can be determined using the formula 14 is equal to pH plus pOH. This formula is derived from the ion product constant Kw, which is equal to the concentration of the hydronium ion times the concentration of the hydroxide ion. Product of these ions' concentration is equal to 1.0 times 10 to the minus 14. By taking the negative log of both sides and expanding using the log rules, negative log Kw is pKw, which is the negative log of 1.0 times 10 to the minus 14 is equal to 14. The negative log of hydronium ion concentration is pH, and the negative log of hydroxide ion concentration is pOH. This gives the formula 14 is equal to pH plus pOH. A question to consider. Determine the concentration of the hydronium ion, the concentration of hydroxide ion, the pOH or pH if given one of these values. So for example, given the pH is equal to 3.32, find the three other terms. To find pOH, use this formula. pH plus pOH is equal to 14. So the pOH is equal to 14 minus 3.32 is equal to 10.68. To find the concentration of the hydroxide ion, this is done by taking 10 to the power of negative pOH. So the concentration of OH minus is equal to 10 to the minus 10.68. This is equal to 2.09 times 10 to the minus 11. Don't forget the concentration units of m for moles per liter. Similarly, to find the pH, 10 to the power of negative pH will give you the concentration of H plus ions. The concentration of H plus ions equals 10 to the minus 3.32 is equal to 4.79 times 10 to the minus 4 moles per liter. Here is a quick check. The ion product constant Kw is equal to concentration of H plus times the concentration of OH minus is equal to 1.0 times 10 to the minus 14. So multiplying concentration of OH minus with the concentration of H plus should give 1.0 times 10 to the minus 14.